So you signed up for biology, and here we are starting with chemistry. Well, one of the reasons why we start with chemistry is because biology is all about energy. And we are starting with chemistry because we are interested in electrons. Electrons carry this inherent energy, so their behavior is going to be very important for biology. So your homework has been to work on the shell models for the first 10 elements in the periodic table. Now let's start with hydrogen. Hydrogen has an atomic number of 1. So if you look at the periodic table, you see it represented like this, right? And this is my atomic number. Now, to make a sketch of the shell model, what I want to do is kind of start with basically the nucleus. And so here's my atomic nucleus. And what I know with that atomic nucleus is that there is 1 proton in there. But the shell model, we're really going to look at those energy levels. So I'm going to sketch in my first energy level here. And in my first energy level, I can put 2 electrons. So if you remember, our rule of thumb is going to be 2, 8, 8. I can put 2 electrons in the first energy level, 8 electrons in the second, and 8 electrons in the third energy level. And that's about as far as we will go this semester in this course. So here is a basic sketch, and to make this represent an atom of hydrogen, now all I have to do is go ahead and throw in 1 electron. So there's my electron. I can also then go ahead and label it down here so that everybody knows that this is the shell model for hydrogen. Now I could ask you some questions about it, right? Even if I hadn't shown you this information, I could say, just look at the shell model and tell me how many vacancies are in the outermost energy level or the outermost shell of this particular atom. Well, I think what you would remember is that there are 2 possibilities in terms of openings in this first energy level. I've got 1 taken, and that means that I have 1 vacancy. Now, once I get this vacancy filled, I would have to move on to the next energy level or the next shell. So let's kind of take a look at an atom that would work that way. So if I look at, for instance, if I move on in the periodic table, I come to an element lithium. And if I look at it closely, it has an atomic number of 3. So what would that look like in terms of a shell model? Well, again, I'm going to start with the nucleus. That's my atomic nucleus. And I'm going to sketch in the first energy level. And for this one, I know that I have 2 electrons that need to go in there. But when I look at lithium, I've got that 3rd electron. Well, it can't go in this first energy level. It's now full. So what do? I sketch my second energy level. And I'm going to go ahead and put in my 3rd electron. So this is lithium. Now, if someone asked me how many vacancies are there in lithium, in an atom of lithium, what I could do is I could say, well, there's 1 electron in this outermost shell, but then I'd have a vacancy there, and I kind of like to group mine. I have vacancies there, I have vacancies here. So those are all my vacancies. So it looks like I have 7 vacancies. And this is going to be really important because atoms with outermost shells that are not filled or unfilled are going to want to get together with other atoms, hang out with other atoms, and form these really incredible relationships that we will be talking about. Some of them will form ionic bonds or ionic relationships. Some of them are going to form covalent relationships where they hang out and share electrons, because the goal is to get your outermost shell full so that you're more stable. And if you have to come together with someone, that will work. So we'll be talking about that next. But your job is to go all the way through neon in the periodic table and make these sketches. If you have any questions, let me know. I'm here to help. You can drop into my office, or you can post in our question and answer page on Canvas.